Dear students, welcome back to the Signals and System video lecture series. This is the last class I'm going to cover in the first unit. In this class, I'm going to revise few fundamental things about the signals and system, and I'm going to cover one of the important classifications of signals. We know that signal is a physical phenomenon and it can be dependent on one or more independent variable and which is used to convey the information. Signal is nothing but it is a function of time. It can be dependent on one or more independent variables and which is used to carry the information. Signal or function are nothing but these are the functions of one or more independent variable which contain some information. Examples we have discussed: voice signal, video signal, signals on telephone, wires, etc. All this. Here the point is very clear. Noise is also signal, but it is undesired signal. So we design any system to have with the very minimal noise or without noise signal. Noise is also a signal, but it is unwanted signal. It is undesired. Then the types of signals we have discussed: continuous time signal and the discrete time signal. Continuous time signal is the one in which the amplitude of a signal is continuous with respect to the time. Amplitude is continuous and the time is also continuous. That is called as continuous time signal. Coming to the discrete time signal, signal will be defined at a discrete time instant. So that is called discrete time signals. Deterministic and the random signals. Deterministic signal is a one which can be computed with the mathematical equations, and sometimes we can call it is probabilistic signal. The random signal, the output, it can't be predefined. That signal is called as random signal. Particularly in this video, I'm going to discuss about the energy signal and the power signal, even signal and odd signal. Anyway, periodic signals and aperiodic signals will be the first topic in the second unit. Then I'm going to talk about the energy signals. Generally, energy signal can be denoted with E. If it is continuous time signal, it is E of t. If it is a discrete time energy signal, that is E of n. A signal can be categorized into energy signal or power signal. An energy signal has infinite energy. That means what? If we calculate the energy of a given signal, that must be a finite energy. That means what? The value must be positive, energy must be a positive only. That must be a zero less than energy of that signal less than infinite. Finite energy. That means what? When you calculate the energy of a signal, if it is between the 0 and infinity, then we can call it as an energy signal. So if it is, if you are going through one particular signal, you are calculating the energy of that particular signal. If you get the infinite energy, then that signal can't be considered or categorized as an energy signal. In other words, energy signals have values only in the limited time duration. Limited time, that means what? For example, if we have the one particular signal, that signal can be defined in the limited time interval. So, for example, a signal having only one square pulse is an energy signal. If you go with the square signal, and if it is having only one square pulse, that means what? For example, the signal is started at 0, assume that, and 0 to t it is having 1 square, 0 to t it is having 1 square pulse. That means what? 0 is a finite value and t is also finite value, but the signal is there in the limited time duration, 0 to t it is there, so that it is called energy signal. For the same signal, for example, a train of square pulse signal is there from minus infinity to plus infinity, minus infinity to plus infinity. In such cases, that is not a finite, that is not finite duration, limited duration time, so that energy signal have values only in the limited time duration. A signal that decays exponentially has finite energy, so that it can also an energy signal. For example, we have an exponential signal. As the t increases, always t must be taken on x-axis and the amplitude must be taken on y-axis. As the t increases, if the amplitude of the signal exponentially decreases, in that cases we can get the energy of a signal. It's a finite value. A signal that decays exponentially, that means as the t increases, the value of the amplitude is going to decreases exponentially, then it has the finite energy, so it can be also an energy signal. The power of energy signal is 0. You have to remember this point. We have determined one particular signal and we have classified that signal is an energy signal. If we calculate the power of that energy signal, it must be a 0 because of dividing infinite energy by the finite time. Power is nothing but it is a infinite, and it will be, here we are having the energy is a finite value, and power will be infinite, so that energy will be divided by the infinite time, so that value will be 0. So here mathematical expression for the energy signal E of t. E of t means what? It is a continuous time signal. Limit L tends to infinity, minus infinity to plus infinity, minus infinity to plus infinity, x of t square dt. In the beginning of signals and system classes, I have explained, if we have any signal, if we make the square of that particular signal, and by squaring of that particular signal, if we get the value of that signal is less than infinity, then we can call it as an energy signal. One may ask, the doubt is that just now I have explained it requires to have the finite time duration. Here the signal is there from minus infinity to plus infinity, but we are not going to calculate the signal energy from minus infinity to plus infinity. We are going to calculate the energy of a signal somewhere between the minus infinity to plus infinity, so that it will be the finite one only. And coming to the discrete time energy signal, E of n is equals to, here integration in case of continuous time signals, energy signal can be calculated by making use of integration, because integration will be calculated at every instant of time, because continuous time signals will be there at every instant of time, so that we can make use of the integrations. Coming to the energy signal with respect to the discrete time is what? The signal will be there at a discrete time instant of time only. So that limit n tends to infinity, n is nothing but minus infinity to minus n to capital N, and x of n square sigma n is equals to minus infinity to plus n. From the minus infinity to plus infinity, at every value of n, that is what? For example, n is equals to 0 to infinity. If you go with 0 to 10, take if n is equals to 0 to 10, that means what? At 0 you can have the signal, at 1 you can have the signal, 2 you can have the signal, 3, like that up to 10 you can have the signal. But in between 0 to 1 we are not going to have any signal. That is called discrete time. So that particular time instance only we are summing the energy of the signal, so that we can make use the sigma. This is about energy signal. Coming to the power signal. The power signal has a finite power. Here we have to calculate energy of a signal, and that energy of a signal must be less than infinity. To calculate the energy of the signal, formula is, if it is a continuous time signal, integral minus infinity to plus infinity, and this duration must be a finite one, limited time duration. Integral minus infinity to plus infinity, x of t whole square dt. In case of discrete time and E of n, that is energy of a given signal, here x of n is a given signal, and it is nothing but sigma n is equals to minus infinity to plus infinity x of n square. And coming to the power signal. So power signal can be denoted with P of t in case of continuous time signals, P of n in case of discrete time signal. A power signal has finite power. The power has to be finite. A power signal is not limited in time, any within the bounds you can take. It always exists from beginning to the end, and it never ends. That means what? The periodic signals are the aperiodic signals continuously, that varies with the time. And in case of energy signal, we can calculate the energy of a signal in the limited duration of time, whereas here the power signal is not limited in time. It always exists from beginning to the end, and it never ends. For example, sine wave, if you take, or cosine wave you can take. Sine wave in infinity length and is a power signal. Whereas if you take the square signal, only one single square pulse if you take, that is 0 to t only having, so that you can call it as the energy signal. But if the same square signal is having up to the infinity length, then that will be the power signal. But if you are having the same square signal and you are calculating the energy within the time duration, you are not going for the minus infinity to plus infinity, you are selecting the time limits, then you can calculate the energy of that given signal. The power of an energy signal is 0. That means what? If we calculate the energy signal, and power of that energy signal is 0, because dividing the finite energy signal will be the finite value. It will be divided by infinite time or length, because power can be not limited in the time. So if it is continuous time signal, we can have P of t is equals to, this is the formula, P of t is equals to a limit L tends to infinity 1 by 2L integral of minus L2 plus L. You can replace that L is nothing but minus infinity to plus infinity also. Here limit L tends to infinity 1 by 2L integral minus L2 plus L x of t whole square dt. What is the additional part we have added to get the power signal? That is limit L tends to infinity 1 by 2L. And the remaining part is what? Remaining part is nothing but it is an energy signal. It is E of t whole. So that limit L tends to infinity, and the whatever the part is there in the integral, that is E of t, remaining will be 1 by 2L. So that the relation between the power signal and the energy signal, P of t is equals to, simply we can tell P of t is equals to limit L tends to infinity E of t by 2L. In case of discrete time signals, P of n is equals to limit n tends to infinity 1 by 2n plus 1 sigma n is equals to minus n2 plus n x of n square. This is about the power of a discrete time signal. So significance of energy and power signal. Energy is a measure of how much work we can be done without any consideration of how long it takes to accomplish the work. That means what? Energy is a measure how much work can be done. We are doing some work, and how much work can be done without any consideration of any time. without any consideration how long it takes to accomplish the work. So amount of work carried in not particular time, then that is called as energy. Power is a measure of how quickly the work is done. How much work done is called energy. How fastly that work has done is called power. It is a dependent. Power is a time dependent function because how fast the work has done is called power. How amount of work done is called energy. The difference between the energy and power is that power may be measured at any point in time. Power may be calculated at any point in the given time, while energy has to be measured during a certain time period such as a second or an hour. We have discussed this part also. If the work is transfer of energy, the power is the rate at which the energy being transferred from one object to another object. Obviously, power can be calculated with respect to the time. At what rate that energy being transferred from one object to another object is converted one form to another form is called power. Within a system, the amount of energy is constant. Energy can be neither created or destroyed, we know this one. However, it can be transformed into one form to another form. Here the point is very clear. So some of the points we have to note very clearly, important points. A signal cannot be both energy and power simultaneously. This is the very important point. Also, a signal may be neither energy nor a power signal. Point is very clear. A signal cannot be both energy and power signal simultaneously. At a time, the one signal can't be energy and the power signal. In other words, you can tell this one. At the same time, the given signal is not the energy signal, not the power signal. That means what? If you have a signal, that must be either a energy signal or power signal. Generally, periodic signals are power signals. We know this one. Periodic signals, there is no end for those signals. And generally, aperiodic signals are energy signals. Aperiodic, that means what? There is no periodicity in this source signals. Power of energy signal is 0. Energy of power signal is infinite. Point is very clear. This is the very important point in the objective point of view. Power of energy signal is 0. We have discussed this point. It is 0 and the energy of power signal is infinite. Likewise, you can have the energy signals and the power signals. At the end of the second unit, we are going to solve some of the problems based on the energy signals, power signals. With this, the first unit is completed, and the second unit is very simple one. Within the 6 to 7 classes, that second unit will be complete.